Hi, David.
Hi, Dan.
So modern stream processing frameworks have solved deduplication with exactly once. So why are we focusing on deduplication in this video?
That's a great question. So when folks are thinking about what their stream processing job needs to do, they're breaking it down into some reusable building blocks that they have available to them, things like transforming the stream or enriching the stream, or looking for patterns. But those things aren't really going to work the way you want them to if there are duplicates. But why would those duplicates be there? Well, it has to do with what happens when you choose exactly once stream processing. That comes with a cost, and that cost is additional latency. So for some use cases, that latency is just too much, and they go for at least once guarantees instead.
Okay, I'm convinced. Let's go ahead and dive in. I've seen a lot of people suggest and maybe allude to using a tumbling window to do deduplication is a great way to kind of spot those duplicates. Is there a reason why that may not be the best choice?
There is. Let's talk about why that's a bit of an anti-pattern. I think folks do reach for tumbling windows because that's what the data stream API kind of makes easiest. Let's look at how to do this with Flink SQL, and then we can come back and talk about the data stream API for a second. So here's a table that we want to deduplicate. It's a stream of trades that may have some duplicates in it. These trades each have a unique trade ID. So if we see two events with the same trade ID, we know the second one is a duplicate. And these events have timestamps. These timestamps in this case are being set by the Kafka broker. This is how you specify that to use the timestamp in the Kafka metadata as the timestamp for each event. So now let's think about what happens with tumbling windows. So we've got our original event T1 here, shown in black, and then a duplicate coming soon after in red. Here, fortunately, it landed in the same window, but there's no guarantee that's going to be the case, even if the events are close together in time. So long as the timestamps differ, the duplicate could land in the next window. That's not great. In fact, it's just downright bad.
Yeah, it kind of defeats the whole purpose of detecting duplicates.
Exactly. And that's not the only problem. With windowing, you also have to wait for the end of the window before you see any results at all. And given the nature of how watermarks work, especially in Flink SQL, the late events are going to be dropped. So all around, this is not a great solution. Now, if you are using the data stream API, you can write your own custom process function to do the deduplication. That's relatively straightforward. But you'll need to take into consideration all the things we're going to talk about in this video. If you're using Flink SQL, you need to shift to a different kind of windowing where the window is triggered on every event. If an event is new, you want the output to just come straight away. If the event is a duplicate, you just want to realize that straight away and drop it. No waiting for the end of a window. That's silly. So the way to do that in Flink SQL is with something called over-aggregation, or an over window. And what we're doing here is we're partitioning the stream based on the unique identifier. So we're getting, conceptually, we have a different stream for each unique trade. We're gathering together all of those unique trades, probably only one, but if there are duplicates, there's 2 or 3 or more. And we're specifying how to pick the one we want. And in this case, we want to think of them being sorted in ascending order and take the first one. And any subsequent ones, we just drop. That's how this works.
Okay, so it seems like we're going to be holding on to these records forever, potentially. It seems like that could be a lot of state that we're going to need to keep.
You're right. There's an unbounded amount of state happening here. We don't have to hold the whole record, though. We just have to remember the unique key. We're just holding on to the trade ID, not the whole trade. But still, over time, especially if you're doing really active trading, this is going to be a lot of state. So you're going to have to think about how to deal with that.
Okay, so just to kind of play devil's advocate here, we're using ascending in this case, but what happens if we decide to use descending instead?
You certainly could. There's nothing inherently unworkable about that, but it adds some complication. When you say you want them sorted in descending order, what you're effectively asking for is, instead of giving me the first of the matching of the trades that are duplicated, give me the last one. But asking for the last one is, in a streaming setting, it's not super well defined. You don't know that there won't be another one. So you just have to send out the first one when it comes. And if a duplicate arrives, you have to say, oh, wait a minute. Sorry about that. Forget that. Here's the last one. So you end up with an updating stream as your output.
Oh, gotcha. And that, if I don't have to deal with updating streams, I will take that path any day of the week. Are there any other considerations that we need to keep in mind when we're talking about over-aggregations for detecting these duplicates?
Well, let's just summarize what we've seen and add in a little detail. So we talked about state. The way to handle all that state is to set a state time to live configuration on your table. Think about how long there might be an outage that might cause a duplication. Maybe an hour is enough, something like that. In terms of time, it's great because the over window doesn't actually need watermarks. So you don't have to worry about an idle source. You don't have to worry about late events. It's all just going to work.
Yay.
In terms of handling changelog inputs and outputs, well, the over window can handle an updating stream as its input, but if that's what you have, you'll end up with an updating stream as output. I'd try to avoid all that if you can, but you can make it work. On the output side, you probably want to always say order by ascending so that you avoid the updating output. And I think that's it. This is relatively straightforward.
Awesome. Thanks, David. If you want to dive deeper into Flink, stream processing, and other Apache Kafka topics, head over to developer.confluent.io. Thanks for watching, and we'll see you in the next video.